In this module, we're covering software testing. This is something we introduced earlier in our discussion of quality. Continue here. We'll start out with a discussion of the levels of testing. Part 2 talks about white box testing, and Part 3 black box testing, the difference between white box and black box. Sometimes white box is also called clear box. It's where you can see what the code looks like and you test based on the structure of the code. While black box sort of says it says you can't see what the structure of the code is, so you have to test to some externally visible criteria, such as the requirements. The levels of testing we introduced last time when we were talking about quality. And if you recall that U-shaped chart, we talked about the levels of development on the one side and the levels of testing on the other side. We may have used slightly different names for the tests, but basically the ideas are the same. You go through levels of testing. The lowest level of testing is called the unit test. This is where the individual software developer will test his or her own work. And then I think we called it string test in the other module, sometimes referred to as integration test, where you integrate the modules together. Validation test and system test are even higher levels of testing. So unit test is the individual modules developed by a single or pair of people, okay, if you're going to do pair programming. But it's the individual developer's work which is tested by that developer or those developers, and then later on they're integrated together. Okay? Usually we'll use white box methods in unit testing because you can see the code, and this is probably the only level of testing that will involve white box methods. As we'll see, once you get to too large a program, the number of paths and the number of structures that you have to test, it gets enormous, and it's just combinatorically infeasible, intractable to completely test using white box methods a large program. So at the lowest level here, unit test, we can still use white box methods. Sometimes we'll use black box methods when we're testing to like the interfaces, and make sure the modules will interoperate with other modules properly. And usually some sort of software scaffolding is necessary for doing unit testing. The reason is because the unit you're testing is in isolation from the rest of the application, so you may need stubs for the missing pieces that you need to refer to, or drivers for the missing pieces that actually will invoke the piece of software that you're testing. Integration test is, or string test, where you're stringing together a bunch of modules and integrating them all together. Now, you need a strategy for doing integration testing. Well, the wrong approach would be what is referred to here as the Big Bang approach. This is, we all tend to do this from time to time, and some of us never seem to learn. The Big Bang approach is where you got all these modules and you just integrate them all together all at one time and then let it fly and see if it'll run. And of course, it never runs, it never works. There's always a bug, a defect in there that causes the whole program to fail. And the problem is, if you integrate all of the units together at one time and it fails, you have a very difficult time trying to find out where the failure is. What line of code or lines of code caused contained the defect that caused the failure. It's a much better strategy to start small and then integrate in small amounts of capability at a time and test in this incremental integration strategy. Now, there are various strategies in this incremental integration. Top-down says, in all cases, we can visualize the software pieces in sort of a hierarchical organization, where the top is the centralized controller kind of capability, and the bottom of the hierarchy, the bottom of this tree structure, hierarchical lattice structure, the bottom would be the lowest level modules, the lowest level functionality. Okay, so the top tends to be more of the centralized controlling piece, and the bottom tends to be more of the lowest level capability or functionality. Well, the top-down says let's integrate in the central controlling pieces first, like the main program and the pieces that the main program directly invokes. And then the last pieces to be integrated in this top-down strategy would be the lowest level components, the lowest level functions. The bottom up goes just the opposite. We integrate in, we start with the lowest level functions and we sort of integrate them together to form higher and higher levels of capability until finally, at the very end, the last things we do is we integrate major subsystems together to form the entire large system. Okay, so we build the subsystems up from the bottom up. The outside in and inside out are just combinations of these. The outside in says, well, let's do both. Let's start at the top and work down, and let's start at the bottom and work up, and hopefully we'll meet at the same place at the middle. So you can start building your subsystems, for example, from the bottom up. And you have to identify what the subsystems are. And then you also begin integrating the centralized controlling part, the main program, and the top level pieces, integrate those from the top down, and sort of like stub out the main subsystems in the top down integration, or have like controllers for the subsystems in the bottom up integration of the subsystems, and then eventually replace the stubs and the controllers with the other pieces and integrate everything in. That's the outside in. The inside out says, well, let me start with this inside, definition or specification of the various subsystems, and I will start integrating the subsystems in a top-down integration. Okay, I'm not going to start at the very top, the main program, but I'll start with the sort of controller parts of each subsystem and do a top-down integration of each subsystem. And then also I will do a bottom-up for starting at the subsystem specification level and integrate those subsystems in a bottom-up integration strategy till I get to the whole, everything integrated together as a whole system. That would be the inside-out approach. I think in any case you will focus on critical modules or paths first, and so you're probably not going to do any of these strictly. The two other ways of looking at these incremental integrations is breadth first or depth first. A breadth first integration strategy would be, for example, if I'm doing the top down, I would start with the main program and then I would integrate in all the next level components. And then I would integrate in all of the next level components, all the third level components. And then I would integrate in all the components at the next level and do a very broad integration, very wide, and reach the bottom approximately at the same time in all the paths. The depth first says, let me take a specific capability, a subset of all of the capability, and let me integrate all of the parts of that all the way from the top, from the main program, all the way down to the bottom, to the lowest level component, and integrate just this one little thin slice of my tree. And then I'm going to integrate in, do another top-down integration on another thin slice of the tree, and sort of fill out the tree in sort of going down all the way down to the bottom on little thin parts of the tree, one little part at a time, and until I finally keep doing that until I get the whole tree incremented in. Validation test involves, just as the name implies, validating that I've correctly implemented the software. I'm testing to the requirements specification. In the requirements, frequently you do have testing criteria and validation criteria. This is always black box testing, testing that you can't see the structure, you can't test to the structure of the software, you have to test to the requirements. There are two specific kinds of validation tests that I want to mention. Everybody, I think, knows what beta testing is. This is where you send versions of the software, early versions of the software, out to real customers, let them use the software at their site, and then they regularly report any problems that they encounter. This is a win-win situation for both the developers and the customers. The customers get early visibility and experience using the software, and the developers get all this free testing. Alpha testing, I always wondered why they called it beta testing, and I wondered if there was something called alpha testing. And in fact, there is. Alpha testing is still uses real users, but it's done under controlled conditions at the developer's site. So what we'll do is very early on, we will bring in some typical kinds of users and show them how to use the software, and then we'll watch the users using the software. And when they make a mistake, we can catch it right away. And if there's a bug in the software, a defect in the software, we can fix it pretty quickly and continue our alpha testing like the next day or the next couple of days. One of the advantages of alpha testing is that you can watch, do, for example, usability testing. You can watch the users use it and see how they get confused, see what parts they stumble, parts of for example, the user interface that they stumble on, and so you can test that kind of thing much more carefully in alpha testing, where you have everybody here at your site and you can watch them and respond to any problems that they encounter much more readily than you can in beta testing. Beta testing is sort of, you're out of control here. You can't control what the users do, and you can't even watch them using the product, and you just periodically get these little reports from them. System test, some types of system test. Usually, when we talk about system engineering, we said, well, software and computers are just one part of a large system. Well, that's what system test is. System test tests the whole system: hardware, software, other software people, all the components. We integrate everything together, and then we test the whole system. And things like recovery. Testing, you turn the thing off, shut the power off, see how long it takes to reboot, recover from some sort of a failure. Security testing, see whether or not the software will leak secrets. You can do ethical hacking, for example. You bring in these people that ordinarily would be just hackers and break into systems, but they will work for you to find the security vulnerabilities of your software. Stress testing, right? You stress the thing either with amounts of information or speeds and things like that. And performance testing, just to make sure that the software will perform and use the computing resources efficiently.